Did algebra first prove the square root of 2 is irrational? Have you ever wondered how mathematicians first figured out that the square root of 2 is not a simple fraction? It is a fascinating story that goes back to ancient Greece. The proof that the square root of 2 is irrational did not come from algebra as we know it today. Instead, it originated from the Pythagoreans, who were known for their work in geometry. To understand this concept, let's visualize a square with each side measuring 1 unit. The diagonal of this square represents the square root of 2. The ancient Greeks believed that this diagonal could be expressed as a ratio of 2 whole numbers, which we call a fraction. They used geometric reasoning to show that this assumption leads to a contradiction. Using the Pythagorean theorem, they demonstrated that if the square root of 2 could be written as a fraction, both numbers in that fraction would have to be even. This means they would share a common factor, which contradicts the idea that the fraction is in its simplest form. This contradiction proved that the square root of 2 cannot be expressed as a fraction, making it an irrational number. Later on, algebraic methods provided a clearer way to prove this fact. The algebraic proof uses a technique called proof by contradiction. In this method, you start by assuming that the square root of 2 can be written as a fraction in lowest terms. Then, you show that both the numerator and the denominator must be even, which contradicts the initial assumption. This algebraic approach is more symbolic and uses the properties of even and odd numbers to reach the contradiction. It is important to note that the first proofs of the irrationality of the square root of 2 were geometric, not algebraic. Algebra later offered a more straightforward proof that is widely taught today. Recognizing irrational numbers like the square root of 2 is important in various fields such as engineering, computer science, and physics. In these areas, precise calculations involving lengths, areas, and ratios are essential. Knowing that some numbers cannot be expressed as simple fractions encourages the use of decimal approximations or symbolic expressions in calculations. In summary, while algebra provided a clearer way to prove the irrationality of the square root of 2, the original proof came from geometric reasoning. Understanding this progression helps learners see how algebra builds on earlier mathematical ideas and provides tools to handle numbers and operations more systematically.